At the beginning of the semester, you learned about levels of measurement, that is, nominal level variables, ordinal level variables, and interval level variables. And the level of measurement was based on whether the variable could be ordered and whether it could be precisely ordered. If you recall, nominal level variables had no order at all. This was like favorite color or your social security number. Ordinal level variables were variables with order, but that you couldn't do math on them. They were just imprecisely ordered, like how happy somebody was, rated on an imprecise scale, or a pain scale, where you can't really tell whether the difference between 1 and 2 is the same as the difference between 9 and 10. Then there's interval level variables that have order and precise measurement, like years of education or income measured in dollars. And these are the variables we're looking at right now. In particular, we're going to look at how do you express an association between those variables, or how can you? And one way to do it is with a correlation. The word correlate has entered the common vocabulary, but it actually has a technical meaning in statistics. A correlation is a number that ranges between -1 and +1. And when you encounter a correlation, or when you calculate it, you should keep in mind two things. The correlation has direction and magnitude. Direction is whether the correlation is negative or positive, and the magnitude is how far off the correlation is from 0. Remember, these are two very distinct things. So sometimes people get confused. They see a negative correlation. They think that means the correlation is weak, but actually the negative sign should be interpreted separately from the strength. And we'll talk more about that as we go along. Sometimes, when looking at correlations, we think of the variables, we abbreviate them as x and y. Sometimes that x is the cause or independent variable and y is the effect or dependent variable, but not necessarily. Sometimes just abbreviated x and y. Let's first think about direction and what that means. If we say education and income are positively correlated, what does that mean? That means that as one variable goes up, the other one tends to go up as well. So in other words, the variables go in the same direction, and then there's a positive association. As the number of years of education increase, the amount of money tends to increase, which is probably one of the reasons many of you are here. Negative correlation is when you have two variables that tend to go in opposite directions. So as one variable goes up, the other one goes down. You can think of perhaps a negative correlation as between how often someone attends religious services and how many delinquent acts they commit. There tends to be a negative correlation between those two things. Keep in mind about correlation, we're not saying that one causes the other. So I'm not necessarily saying education causes income or religious service attendance causes delinquency decrease. That may be the case, but I'm not saying that by saying that they're correlated. Correlated just means they tend to go together. But we should be cautious and remember correlation is not causation. Because in order to establish that one thing actually causes something to happen, we need more information than simply that their two variables are correlated. If you think of, we look out in the world and see people with more education tend to make more money than people with less education, although there's plenty of exceptions. But we can't necessarily conclude that education causes income to go up without more information. Why? Because maybe there's other things about more educated people that cause them to make more money than other than just that they have their education, their credentials, and the skills they learn from. They could be just naturally more hardworking or more likely to follow the rules in society, whatever it might be that might cause them to make more money. There's going to be a variety of things. And so, key thing to keep in mind is correlation is not causation. In many cases, people have made that their mantra because it's so important. Many times people see correlation, they assume that means that one variable is causing the other, but it might not be the case. Now let's think about magnitude and what that means. Well, this has to do with the absolute value of the correlation. And the absolute value of a number is simply the distance of that number from 0. So if there's a negative sign, we just lop that off to look at the absolute value. So correlations, we'll start with ones that are close to 0. Remember, correlations range between -1 and 1. -1 and +1. Correlation is literally 0. That means that there's no association between the variables. It means that as x goes up, we can't really say anything about y. On the other hand, correlations that are between -0.3 and in +0.3, but not exactly at 0, these are what we call weak correlations. What does that mean? That means basically there's a pattern, but it's a pattern that admits of a lot of exceptions. Then we have moderate correlations, where the absolute value is between between 0.3 and 0.6. That means they're either down here or up here. Those correlations are, indicate patterns where there's a fair degree of exceptions, but there are, fewer exceptions than in the weak case. And then finally, there's strong correlations that are greater than, with an absolute value greater than 0.6. So they're correlations that are between -1 and -0.6, or between 0.6 and 1. Those are correlations that are just a stronger pattern, meaning they admit of fewer exceptions. Now let's consider a few examples to fix some of the ideas. Let's think of a first sort of absurd example, the lengths of your right legs and the lengths of the left legs. So if we could guess what the correlation there is, probably be pretty strong, almost maybe close to 1. It might be 0.9 there. Why? Because first of all, direction. Well, as one leg goes up, the other one tends to go up. So it's positive. And it's very rare that you have somebody with a short left leg and a taller right leg. So as one goes up, the other one goes up almost in lockstep, because they're both coming from the same source. It would be only be in unusual cases where someone had a very short left leg, if part of their leg was amputated. But in most cases, even if one leg is slightly shorter than the other, basically they're very similar. And if you look across people and you look at the variation across people, and the covariation between the two legs, it's going to be pretty strong. So there are very few exceptions, so it's a strong correlation, strong positive correlation. Education, income, in this case there probably would be a moderate positive correlation, because as education goes up, income goes up, but moderate because there are exceptions, more exceptions than in the case of the length of the legs. There's some people without a college degree making a lot of money. Bill Gates and Mark Zuckerberg being two examples. And there are other people who have a lot of education and don't make very much money. Perhaps, namely, some of your professors who have PhDs, but a professor doesn't pay that well. Then in the third example, hours studied and GPA. Here I'm guessing it's going to be a weak to moderate positive correlation. So in this case, the more hours people study, the better their GPA will tend to be, but it's not always the case because there's other factors going on. So there's exceptions of people who study a lot and don't do so well. Maybe that's why they are studying a lot, is they're really struggling, or people who don't study very much and do well because they just happen to be really smart, or the work that they're doing tends to be easy for them. So in this case, positive, but perhaps weak or moderate because it admits more exceptions. Now, what about number of beers per week and GPA? Well, in this case, definitely it's a negative correlation. Otherwise, we'd all be alcoholics. Presumably, if drinking beer improved your GPA, there wouldn't really be any reason not to drink. But it's a negative correlation, so as the number of beers go up, the GPA tends to go down. But it's probably not as terribly strong because there's going to be a fair number of exceptions. Then we have the last example, which is absurd, toe size and GPA. And in this case, there's probably no correlation. I want to say definitely, but probably no correlation. As the toe size goes up, GPA probably doesn't change much. So there's really no pattern there. There might be a very, very small correlation for some bizarre reason. They have found that people who are taller do better on average in various things. And maybe if toe size is related to height, that could be then related to GPA, but it's probably going to be a pretty small correlation, almost zero. Rarely do you see correlations exactly zero, but if it's small enough by 0.01, then it's almost zero, or negative 0.01. So let's think more about what it means to have correlations of different kinds by looking at some of these just stylized examples. At first, let's think about a correlation that's close to 1. This is what would be called basically almost a perfect correlation. Okay, this is what you would see in the example of right leg and left leg. Okay, where basically if you're high on one thing, you're high on the other thing, and about as high on the other thing. So the dots here are very, very close to the line, indicating that people who are high on one thing are high on the other. There are very few exceptions. That's what you're going to see when the correlation is 1. Basically, all these dots would line up in a line, like a lockstep. Okay. Correlation of -1 would be analogous situation, but just reverse direction. Okay, with all the points lining up very close to the line. It's almost 0.1, so it's not lined up exactly. These are very, very rare cases. You don't just come upon these kinds of things in nature, because if a correlation is this perfect, then this means that you're basically talking about something that's almost the same thing. Like if you have two people's legs, they're coming from the same source of growth. What about moderate correlations? Moderate correlations, you do see a pattern. So in the case of a positive 0.5 correlation, you see that the points are, tend to line up so that if x is low, then y is low, and if x is high, then y tends to be high. But there's also exceptions, like there's this point right here where you have someone who is low in x but high in y. So again, there's a pattern, but there's some exceptions. A correlation about -0.5 would be the line sloping in the opposite direction, negative slope, going down and to the right, and you would have more people, again a pattern where you'd have people who are low on x would be high on y, and vice versa. If you're high on x, low on y, but there would be some exceptions. Still a fairly strong pattern. Weak correlations is, again, just more exceptions to the rule. You have pattern, but there's a lot of noise. There's a lot of other stuff going on, and there's exceptions. And again, you can see in the positive 0.3 case, the line goes up, but there are exceptions to the rule, like this person up here. If it's negative, the line's going down, the regression line's going down here. And the scatter plot tends to follow this line, but there's plenty of exceptions. And then in the case where the correlation is close to 0, the line is basically, it's not going anywhere. It's not going heading up or down. And the points are not arrayed in any sort of pattern. They're just randomly placed. That's a correlation close to 0, which means really x or y doesn't do anything. The variable y doesn't go up or down. If x goes up or down, we can't make any prediction. That reminds me of another way you can think about correlations is and associations is when two variables are correlated, that means you can predict one from the other. So if we know someone's education, we can predict better their income. Right? If we know the length of their left leg, we can predict better the length of their right leg. How strong the correlation tells you how good our prediction is likely to be. If the correlation is, if we're talking about right and left legs, knowing the length of one leg gives us almost perfect information about the length of the other leg. Very few exceptions. On the other hand, with education income, yeah, we can predict that someone with a college degree is going to make more money than someone with a high school degree or a GED, but there's plenty of exceptions, and so prediction is not as good, and so the correlation is moderate rather than very, very strong or almost perfect. So again, the correlation is a single number that is a summary of a relationship between two interval level variables. Correlations range between -1 and +1, and you should interpret them by thinking of their two aspects: their direction, whether they're negative or positive, and their magnitude, the strength, which is the distance from 0. And I mentioned there are these rules of thumb about how strong the correlation is and whether we consider it weak, moderate, or strong. Sometimes there's quibbles with the exact rules of thumb there, but they're basically accepted. Rarely you're going to get a correlation exactly equal to 0, but if the correlation is 0.01 or -0.01, or somewhere very, very close to 0, there's zeros after the decimal point, then it means that there's not much of a pattern. So you're going to look at correlations in a number of respects. You're going to look at correlation between the size and price of condominium, the age and price of used cars, and you're going to look at data from Rate My Professor, where you look at correlation between how easy people rate the professor and how helpful they find the professor. And hopefully all of these exercises will reinforce the idea of correlations in your mind.